Who's ready for some serious stoichiometry? Don't all raise your hand at once. All right, as you take a look at this problem, it says, consider the reactions of the Ostwald process for the production of nitric acid below. What mass of NH3 would be needed to produce 126 grams of HNO3? The first two reactions have 50% yields and the last reaction has 25% yield. Okay, so don't panic. I know it can look really intense when you're trying to do stoichiometry with multiple equations, but really it's just 3 times the fun. We're trying to figure out mass of NH3 in order to produce 126 grams of HNO3. So basically, we're going to work backwards here. I'm going to start with my 126 grams of HNO3. Now, as I scan my equations, I find that it appears here in the last equation. And I'm trying to figure out, ultimately, this, NH3. First thing I'm going to do is convert to moles of HNO3. All right, molar mass time. 3 oxygen, each at 16. 16 times 3 is 48. Got a nitrogen here, which is about 14, and a hydrogen, which is going to be 1. So 48 plus 14 is 62 plus 1, about 63 grams. Ooh, that's going to work out real nice. I'm going to go from moles of HNO3 to moles of NO2. And again, the reason why I'm going to NO2 is I'm trying to work my way back to NH3. The relationship between these two things is 2 to 1. So let's solve this. 126 grams times 1 divided by 63. I have about 2 moles of HNO3 here. Times 2 moles, I'm going to need 4 moles of NO2. Okay, so here's the tricky part though about this problem. 4 moles of NO2 will give me my 2 moles or 126 grams of HNO3, assuming that I had 100% yield. But this reaction is only going to give me 25% yield, or I'm only going to get a quarter of what I expect to get. In other words, I need to start with 4 times the amount of reactant so that I end up with the amount of product that I actually want. So 4 times 4, I actually need 16 moles of NO2. Again, think about it. If I had 16 moles of NO2, using the stoichiometry in the equation, that would give me 8 moles of HNO3. But that's at 100% yield. I only get 25% of that. And what's 25% of 8? You guessed it, 2 moles, or 126 grams of HNO3. Okay, so what is it going to take to get 16 moles of NO2 from NO? Let's go back here. I'm going to do moles NO2 to moles of NO. Here my ratio is 2 to 2. It's going to be 16 moles of NO. But again, keep in mind, that's assuming 100% yield. If I started with 16 moles of NO, I would get 16 moles if it was 100%. But it's only a 50% yield. In other words, I'm only going to get half of what I expect to get. So if I want 16 moles of NO2, I need to start with double the expected amount of NO, or 32 moles of NO. Okay, so what is it going to take to get 32 moles of NO from NH3? For every 4 moles of NO, 4 moles of NH3, which means I'm going to get 32 moles of NH3. But that's the amount, again, assuming 100% yield. And that first reaction is only going to be a 50% yield again. So I need to start with double the amount, or 64 moles of NH3. And again, confusing, I know, but let's work it forward now. If I had 64 moles of NH3, I would make 64 moles of NO, assuming 100% yield, but it's only 50%. So I'm actually only going to make 32 moles of NO. My 32 moles of NO would make 32 moles of NO2. But again, I'm only going to make 50%, or 16 moles of NO2. 16 moles of NO2 is only going to make 8 moles of HNO3, again assuming 100% yield, but we only have 25% yield. So what's 25% of 8? 2 moles, or 126 grams of HNO3. Now, as I scan my answer choices, there is no 64. Oh my goodness, all this work and I still haven't come up with the answer. We're asked for mass in grams of NH3. So, final step. I know that I need, my final step, I know that I need 64 moles of NH3. Each mole of NH3 is about 17 grams. I think the easiest way to do it is just to assume a molar mass of 20 grams. 64 times 10 would be 640, and then again times 10 would be another 640, which means that our rough estimate in the mass is going to be about 1280. But we kind of overestimated that mass, so it should be less than 1280. And as I look at my answer choices, the only answer that makes sense or comes relatively close, answer choice D.